Okay, welcome to the video here. I just got it right size. One thing I've learned is just because the answers on the slides doesn't mean they always make sense, just because they're visually there. So I'd like to spend a little bit of time and go through the solutions that you saw and make sure you understand them. If you did understand them all, it's going to be repetitive and maybe you don't have to watch the video. But if you didn't, here we go. Right, if you remember, get the red. Whenever we have the square root, we don't ever have to put the index, but it is 2, right? And what happens is I can rewrite this, instead of using a square root, I can use a fractional exponent, right? I can make it 2 to the 1/2, right? We did that a few slides ago. It's just a different way of writing it instead of square root to the 1/2. The advantage here is from my exponent laws from a couple weeks ago. If I have two exponents like this, I multiply the exponents together. So if I multiply the exponents, well, 2 times 1/2 is just 1. So I have z to the 1, and as you know, mathematicians, we don't ever show the exponent 1, so we just show z. Okay? So that's how that one broke down. Let's look at the second one. Very similarly, okay, let's do an extra step here before I say very similarly. I can do the square root of 49, right, times the square root of t squared, right? Because if I'm multiplying, if I have a square root and a square root, I can multiply the radicands and get 49t squared inside. Now, as soon as you know you can do that, well, I can take the square root of 49, which is 7, okay? And the same way that the square root of z squared was z, the square root of t squared will be t in the exact same manner, which means this is 7t, right? And that's where you get the answer, okay? I use the exact same approach with this for the t squared to get the t, okay? Basically, you divide the exponent by 2. Okay? Let's look at the third one. The third one has a couple of things that, let's do it in a different color here so you can separate it. Okay, we're going to do the square root of 18 and the square root of b to the 14. Okay? Now, unfortunately, the square root of 18 is not a perfect square. It's not nice like this. So the best we can do is simplify it and say the square root of 18 is the square root of 9 times the square root of 2, right? Square root of 9 times the square root of 2. Now what we can do with the b is we can write that as b to the 14 to the 1/2, right? Same way we did here. That helps us out a little bit. Okay? Now, square root of 9 is 3. The square root of 2, we cannot do anything with it. We leave it as square root of 2. Here, we can multiply the exponents. 14 times 1/2 is 7. So we can say that as b to the 7. So here, I'll step away again. Right? So we have 3 root 2b to the 7. Now, traditionally in math, the root 2 or the root whatever is written at the end. And on the slide, you'll see it shows 3b to the 7th root 2. So we reorder it 3b to the 7th root 2, right? Now, there's a couple reasons for that. One, it's math practice that you put the root at the end. So I put everything that's not in the root at the beginning, right? And you might say, well, what's the difference? The difference is if you write things sloppy and you do this, if I'm going with this, I got 3 root 2, I got b to the 7th. Ooh, hold on. Did I mean to extend that root 2? Is the b inside? Is the exponent outside? Is that supposed to be there? And all those questions of sloppy writing get eliminated when you just put the square root at the end. Okay. Let's look at the last one. Okay. Let's look at the last one. Well, we'll kind of create some, a little tight here, but we'll create some space. Okay. 32. So what we can do, the same way we broke it up when we were multiplying it, I can say this is equal to the square root of 32 over the square root of n to the 20th. Okay, let me just let you see that for a sec. Okay. So I can, instead of having them in one square root, I can have them in two square roots. Okay. Again, the square root of 32 is not a perfect square, but the largest perfect square I can divide out of it would be the square root of 16. Right? And again, n to the 20th, well, it's a square root, so I can say this is n to the 20 to the 1/2. I'll just give you a second to have a look at that. Okay, n to the 20 to the 1/2. All right, so now I can say this is a 4 root 2. 20 times 1/2 is 10 over n to the 10. 4 root 2 over n to the 10. So it's simplified. Okay, it's still messy. I'm not going to suggest this is really any neater than this, but it's simplified because we've taken everything we possibly can out of the square root, which makes the square root, or the radical piece, much smaller than it was, and everything else is taken out. Gotta love all the little pieces, eh?